There are many models of addition and subtraction. In this video, we will be looking at the Numberline model, which is also called the measurement model. Those are the same thing, numberline and measurement. We will be looking at the method that's presented in the textbook Mathematical Reasoning for Elementary Teachers by Long, DeTemple, and Millman. There are other ways of using the Numberline model or the measurement model, but the model that's presented by these authors is a particularly good one because students can use it in their elementary years when they're working just with positive numbers, but it's something that carries over into their pre-algebra and their algebra experience when they're working with negatives. So we have some definitions. Addition for us is going to be head to tail. Now, when we worked with the set model of addition, we said that addition was pushed together. That's how we defined addition, it's pushed together. Well, on a number line for us, addition is going to be connecting arrows head to tail. Subtraction, when we worked with the takeaway model, subtraction was literally takeaway. But for the numberline model, it's going to be head to head. A right pointing arrow is going to represent a positive number, and a left pointing arrow is going to represent a negative number. So one of the really strong features of this particular representation of this model is that we have a way of representing subtraction and a way of representing negative numbers. If you're just kind of doing this in a haphazard way, how do you help your students understand how to do something like subtracting a negative? What would that mean and what would you do? So for now, we're only going to concentrate on whole numbers, and we are only going to look at two problems, 4 plus 3 and 4 minus 3. And at first, I'll just reiterate that there are many ways you can do this. Some teachers might help their students by saying, oh, this is 4 plus 3. Let's start at 4 and count 1, 2, 3 more. So the answer to 4 plus 3 is 7. So obviously this is not the model I just showed you, but this is how this is sometimes done in the classroom, and it works. It helps students understand addition, it helps them begin to learn their facts. Or perhaps the teacher will have the student represent both numbers, in which case you start at 0 and you count off 1, 2, 3, 4, and you go from there and count another 3, 1, 2, 3, and of course, in this case, we also end at the 7, so 4 plus 3 is equal to 7. With the model that I am presenting in this class that I'm making this video for, what we actually do is represent both of the numbers. We will always start at 0. We'll represent both numbers. Here's the 4. And then we will also represent the 3 by an arrow that's 3 spaces long and pointing to the right, and we're going to connect that head to tail. So the arrow is the head, and here's 1, 2, 3. Notice with this method I also land on 7, which we were expecting. I have a right-facing arrow representing 4, a right-facing arrow representing 3, it's 3 spaces long, and we land on 7. One nice way to present this to students is to use a transparency overlay, because then we can say, look, I have a 4 here and I have a 3 here. And what I'm doing is representing my 4 and I'm representing my 3. One jump follows right after the other. We land on 7, so 7 is the result. 4 plus 3 is equal to 7. One of the things you'll see in the textbook is that the authors sometimes insert another arrow using a dotted line. They call this a resultant. That's not something that I'm going to expect. You may or may not find that helpful. So moving on to our subtraction. Again, you know, sort of an intuitive way to do this might be to say, hey, start at 4 and take away 3. So you're going to start at 4 and you're going to hop backwards 1, 2, 3. and we get a result of 1, which we know is correct. That is a way of doing subtraction. It works, it's helpful, but it's not the method that we're covering. Similarly, you could represent the 4 and then the 3. Well, we're going to go 4 spaces, 1, 2, 3, 4, and then we're going to jump back 1, 2, 3, because we are subtracting instead of adding, and so the result there is also positive 1. But let's take another look at the rules from our textbook. So we are now doing subtraction. Instead of connecting head to tail, which was addition, 1 arrow and then boop, another jump, another arrow at the end, we're going to connect head to head. We're going to continue to use right pointing arrows to represent a positive number. If you just draw this, it looks a little bit odd, but this is what it's like. Here is 4. That's a positive 4. It's an arrow that covers 4 spaces and it points to the right. Now I need to do takeaway, so I'm going to connect the arrow right here where this other arrow is, and I'm going to make, an arc with an arrow on it that's 3 spaces long. Connecting head to head, this is what I get, and if we were to draw a resultant, we would draw a little dotted line to here. Now I know this seems less intuitive. It probably doesn't seem to make as much sense at first as doing this or doing this. But as we'll see in a later video, if you adopt this method and get used to this method, it's going to be helpful to your students and they're going to be able to carry this on into their pre-algebra and algebra work. I think it helps quite a lot to use these pre-constructed arrows, at least when you get started with your students. So let's do this again. So I want to do 4 minus 3, so there's my 4. I start at 0, and I'm representing the positive number 4. And what I'm thinking about next is I'm thinking about actually removing a jump of 3. This is subtraction, right? I'm removing something. We've jumped 4 spaces over. Well, now let's take the number 3 and connect it head to head, and what we're going to do then is remove a jump of 3, which is going to leave us at 1. I find that helpful for myself to think of subtraction as being removing a jump, and that's what we accomplish when we connect the arrows head to head.